Okay, so the next topic that we will be covering is the natural language processing. So, nowadays, most of the natural language processing is done using deep learning methods, but there are also other methods which are used for natural language processing. So, we'll just have an overview of all the methods which are used for natural language processing basically. So we can say that natural language processing is concerned with the interaction between the computers and the human. Okay, so if the human interacts with the computer in the language in which they talk, okay, then the computer needs to understand that language and work on that language. So that is what is known as the natural language processing. So NLP explores how the computers understand and manipulate the natural language text or speech, right? So all these three are what you need to basically see. So you have to see how the computer can understand the text, okay, and the spoken words in the same way as the human being does. Okay, that's what we are trying to do. So what we do is that there are some tools and techniques which are there which will help the computer understand and manipulate the natural language. So basically we'll go through these type of tools and techniques which are there. And it's also possible that the computer needs to also interact with the human being using the language which the human being understands. Okay, so it may be typewritten text or spoken language, etc. So what is it that can be achieved? So this is just a overall summary slide type of thing, like how would you talk to your phone and ask it to do something, and use the web to get answers for what you want, map out discussions in books, translate between one language and another language, summarize documents, answer questions, okay, sentiment, a sentence that you have, what is the sentiment, etc. So these are the type of things that you need to achieve basically. So these are some of the areas which are related to natural language processing. One is information retrieval, machine readable dictionaries. Okay, so dictionaries are a very important aspect of natural language processing because it needs to find the meanings of the words and use the meanings of the words in a semantic way to get the understanding of what is happening. And another important topic is the speech synthesis and recognition when you are working with speech, right? And cross language information retrieval. For example, if you are if the system is if the computer is interacting with a person from Russia or it's interacting with a person from India or a person from France, so can it retrieve information or can it talk in different languages or convert one language to another language, etc. Okay, so these are some tasks. So these tasks which are given in blue are the applications, and you could say that these are tasks which help you to do the tasks which are given in blue. Okay, so you could have things like co-reference resolution where determine which words refer to the same object. Okay, so for example, if you are talking in the first sentence about some person and in the second sentence you start with he went somewhere. Okay, so who does that he refer to, right? So that type of thing is the co-reference resolution. Discourse analysis, discourse relationship between sentences, right? Recognizing the speech acts. Morphological segmentation. So you separate the words into morphemes. Okay, so that's the smallest unit of speech, right? So that is the segmentation that you can carry out. Then named entity recognition, which is identifying certain words and categorizing them. Okay, so we will see what this actually refers to. Then we have optical character recognition. So you have to recognize first of all if it is say written by hand or whatever, then what is it that the word is, right? So that is done by optical character recognition. Then you have the parts of speech tagging. So suppose you have a sentence, what is the part of speech of each of the words? Okay, is it a noun, is it a verb, etc. And parsing of the sentence. Okay, so we use a phrase structure. Okay, so we have the noun phrase and the verb phrase. Then the noun phrase is divided up, the verb phrase is divided up, etc. to do the parsing. And then we have the relationship extraction. So if you have two nouns, then what is the relationship between those two nouns? For example, who is married to who, etc. And sentence breaking. Okay, find the sentence boundaries. Where does one sentence finish and the next sentence start? Speech segmentation, topic segmentation and recognition, word segmentation. Word sense disambiguation means there may be a particular sentence may have a number of possible meanings. Okay, so out of that, which is the meaning that you are going to select for the sentence that you have, right? So that gives some of the tasks. Native language identification. So in other words, if the person is speaking in some non-native language, okay, maybe he is speaking in English, but he is a French person, can you identify that his native language is French? Then you have stemming. Stemming is converting the text to its root form. Okay, so if you have, say, something which says he was running, right? So running is one of the words in the sentence, but you need to convert that to the root form to make it easier to work with. So it will be the root form will be run, right? So that you can look that up in your dictionary, etc. Speech simplification, can you remove the complexity and make the speech simple? Text proofing, that is correction, can you correct the sentences? Natural language search, query expansion, that is for searching for the relevant documents. Automated essay scoring, okay, true casing. So can you find the proper capitalization of words? Okay, so these are some tasks which we talked about. And if we look at the blue tasks, automatic summarization, machine translation, natural language generation, natural language understanding, question answering, sentiment analysis, speech recognition. These are some of the applications: information retrieval, information extraction, speech processing, etc. Okay. So when you communicate in natural language, you have a sentence which will consist of, each word will consist of a part of speech, right? And you have the phrase structure is used, okay? And there are different types of grammars. So the most common here is the context-free grammar, regular grammars, etc. So you have what is called the grammar, right? So this is the grammar for natural language, where you say a sentence will consist of the noun phrase and the verb phrase, or it could consist of a sentence with conjunction with another sentence, etc. So the noun phrase could be a pronoun, it could be a name, it could be a noun, etc. And the verb phrase will be a verb phrase and a noun phrase, a verb phrase and an adjective, etc. And then what is an adjective? Okay, what is a PEP? Okay, past participle, etc. Relative clause, what is it? So all these things together form the grammar which you are using, right? So whatever text you are writing should follow the grammar which is given here. Okay, if it follows the grammar, just like we saw in the logic, right? If it follows the grammar, then we say that it's a well-formed sentence. Any place where it does not follow the grammar, we say that it does not follow the syntax of the grammar. So where does the ambiguity come? Okay, we have seen that if you take a language like English, okay, English is an expressive language. We need an expressive language, but at the same time, there's a lot of ambiguity in the language. So where does this ambiguity come? We need to see how this ambiguity comes. First of all, we have the lexical ambiguity. A word can have more than one meaning. For example, if you say bank, it could be a bank where you do your financial transactions, or it could be the bank of a river, etc. Right, so you have more than one meaning for some words, right? The second one is the syntactic ambiguity. It can be parsed in multiple ways. Okay, so we are going to parse the sentence, and that can be done in a number of ways. And third one is the semantic ambiguity. You can have many interpretations of the same sentence. And there could be an ambiguity between the literal and figurative meaning. Okay, so we know that we have a lot of figurative speech in English. Okay, so you use things like what is called the metonymy, where a figure of speech where one object is used to stand for another. Okay, or a metaphor. A phrase with one literal meaning is used to suggest a different meaning by analogy, right? So you find that all these things are used, making the ambiguity more, basically. So what do you do in such a case? You have to carry out what is called disambiguation. So what you do in disambiguation basically is you take all the meanings of that particular sentence, right? And each one will be given a probability. Okay, so the probability is supposed to show how probable it is that this is the meaning which you are using. Okay, and this actually is based on all these four models which we use here, and it will have probability given by using all these four models, which are then combined together. So the first one is what is called the world model, that is the likelihood that a proposition occurs in the world. Okay. For example, if the speaker says I am dead, it's more likely to mean that I am in big trouble rather than that my life is ended or some such thing, right? The second one is called the mental model, the likelihood that the speaker forms the intention of communicating a certain fact to the hearer. Okay. The third one is what is called the language model, the likelihood that a certain string of words will be chosen, given that the speaker had the intention of communicating a certain fact. And the fourth one is what is called the acoustic model, which is only for spoken communication. So spoken communication, likelihood that a particular sequence of sounds will be generated. Okay, so it uses all these models to get some probability, and using these probabilities it will decide which is the most likely interpretation for the sentence that you are using. So when agents communicate with each other, so you have a set of agents which are working together, right? So when they communicate with each other, they have a certain subset of speech acts, okay, which they use to communicate with each other. But these are the actions which are available to an agent. So it could be like you may be informing the other agent about parts of the world, okay, which you have explored, or you can be querying the other agent about another aspect of the world, or you may be answering questions, you may give a request or a command, promise to do something or offer some deal, acknowledge some request, share experiences, etc. So this is the type of communication you find between two different agents. So basically when you have a number of agents and agents communicate with each other, they use what is called ask and tell. Okay. So agent A can communicate proposition P to agent B by saying tell agent B P, okay, or it can ask agent B some query Q, right. For example, you can tell knowledge base B that there is a pit at P1 and P1 is at position 2, 3 at a situation S, okay, current situation. So this is the way you need to communicate. Okay. So here actually when there is a communication between speaker S and here a H, okay, you need to go through these. So S wants H to believe some P, right, and he chooses words W and he utters or types those words, okay, and H will look at W dash, okay, so W dash ideally should be equal to W but may not be equal to W, okay, and then it analyzes for all the possible meanings, say P1 to Pn, and then it carries out disambiguation and decides that the intended meaning was Pi, okay. Ideally Pi should be equal to P, whatever P was given over there, and then H will decide to believe that the speaker wanted to say Pi or convey Pi, okay. So this is the way the communication is there between a speaker and a hearer basically. So let us see first of all how do you represent the documents, because the representation is actually very important because that is how the document is communicated, okay. So suppose I have a document DJ, you could have what is called the vector space model where you say you have word 1, word 2, all these words are there, okay. So you are saying all these words are there in the document DJ, okay. You could also have the weight for each of the words, right. So that weight could be something like how many times it occurs. Then you have the bag of words model where it just contains all the words in the bag and each word it will have frequency of occurrence, okay. So it is a orderless document representation giving the frequency of words. So for example, you can have say document 1, document 2, document 3, and if you take all these words, how many times does it appear in that document? It appears 27 times in document 1, it occurs 4 times in document 2, etc. So this is called the bag of words model. And then how do you convert text into features, okay. So you have a sentence, you want to convert it into a vector like this of real numbers which you are going to feed into your deep learning network, or you could also use it for in other ways, right. So basically one representation is we got to represent the text in the form of a vector or an array. So you could use one hot encoding, okay, which we saw earlier basically. So one hot encoding means that suppose it comes there, I'll tell you later about that. You can use bag of words, you can use the TF-IDF model. So term frequency inverse document frequency is, this is the equation which you can use over there. And then you can use different ways of finding word embeddings, for example word2vec, glove or fasttext, etc. Right. We have seen this a little bit when we did the deep learning part. So let us see how the one hot embedding works, okay. So suppose we have something like have a good day, etc. So suppose you have say n words in your data set. Each word will be represented by one of the elements in your data set. So basically that element will be 1 and the rest of the elements will be 0. So that type of representation is what is called the one hot encoding basically. Okay. And word to vec basically you are representing each word as a multi-dimensional vector. Okay. And you are using shallow networks. So you are using a network like this, okay, where you are giving the input, that is the words and the association between words, etc. And the output which you are getting here will be your word embedding basically. Okay, we won't go into more details than that. So you have something called word to vec, so which is available, and you can use word to vec to convert words in a document to a vector basically. Okay, now suppose we have a sentence, okay, how do we try to understand the natural language which is there, right? So what you do is you begin at the word level basically, okay, so at the word level you have the words, okay, so you have to determine the morphological structure, a part of speech, okay, meaning of the words, etc. So meaning you can get from the lexicon or the dictionary, right? And then you move to the sentence level. So you determine word order, use the grammar to see whether the syntax is right and see the meaning of the entire sentence. Then you move to the context and the overall environment. So at the word level, what do? You have to do part of speech tagging, that is each word has a part of speech. So part of speech tagging is called grammatical tagging, okay. So these are the two methods which you can use. You can use a symbolic method. So you have a set of rules which tell you, using those set of rules you can decide what part of speech it is, right? Or you can use a statistical method where you can use a machine learning algorithm which would have learned from a number of examples, right? Yeah, so they make use of things like HMM and conditional random field, etc., which is trained using a large corpus of labeled data basically. Okay, then when you come to the sentence level, you have to do the parsing, right? So how do you do? Parse is the process of determining the syntactic structure of the text. And after parsing, you get what is called the parse tree. Okay, so let's see what the parse tree is. So this is your parse tree. Suppose you have a sentence. So you have a sentence called I like mangoes. So you have to divide the sentence into the noun phrase and the verb phrase. So the noun phrase is I, then the noun phrase, the verb phrase is like mangoes. Then you have to separate this out into verb and noun phrase again, okay. And this whole thing is what is called your parse tree, okay. Then lexical semantics, you have found the meaning of the words, okay, referring to dictionaries and obtaining the properties of words. Then the compositional semantics, so when you combine the words together, what is the larger meaning that you are getting? Then you have to carry out word sense disambiguation. We just saw how you carry out the disambiguation. So what are the problems you may face here? Polysemy, words that have several meanings. The same word can have a number of meanings. Or you can have the synonymy where you have different words but they have the similar meaning, okay. So these things are the ones which are likely to cause problems, and mainly you use things like WordNet and other things like FrameNet, ConceptNet, etc. over here. So this is how you find the lexical analysis of a word. So suppose you look up dog, this is what you will get. It will say it's noun, it's a noun, it takes S in the plural, it's animate, it's four-legged, it's a carnivore, etc. Right? So these are the semantic properties, this is the morphological property, this is the lexical property, etc. So when you do natural language understanding, you have to distinguish the 7 levels. Phonetic or phonological level, which deals with pronunciation, morphological level, lexical level, syntactic level. Okay, morphological level deals with the small parts of the word, the suffixes, prefixes. Lexical level, syntactic level, which is the grammar and structure of sentences, semantic level with the meaning of the words, discourse level, which deals with document structure, and pragmatic level, which deals with the knowledge which comes from the outside, basically. Okay, so text analytics is the process of drawing meaning out of written communication, and it uses all these various techniques, things like summarization, visualization, text identification, text mining, etc. Right? So these are some application of text analytics. Computational linguistics is a subset of NLP. Okay, so you are using computational linguistics to actually solve things like semantics, etc., syntax, all the problems that we are talking about. And you also have more specialized topics like socio-linguistics, psycholinguistics, applied text analysis, data intensive computing, etc. Right? So one problem we talked about was named entity recognition. So what does that mean? You are identifying specific words or phrases and categorizing them. For example, it could be a person's name, a person location, a particular location, a disease, a medication, etc. Okay, so it identifies proper names and classifies into predefined categories of interest: person, location, organization, measures, okay, etc. So what is it that it sees? First of all, it will see the case. Okay, does it start with the capital letter? Is it uppercased? Is it mixed case? Then punctuation, does it end with a full stop? Does it have periods inside? Does it have apostrophe, ampersand, etc.? And then is it a digit? Is it a digit with the words or the Roman numbers, cardinal numbers, etc.? Is it a character, morphology? Is it a prefix or a suffix? What part of speech? And what is the function? Okay, all these things are taken into account. And finally, what you are getting is named entity recognition. Example is given here. So if we have a document like this, you find that there are 4 things which are going into named entity recognition: name, place, organization, quantity. So it will take this one as a name, okay, San Francisco as a place, Bangalore, India as a place, 1.3 million is a quantity, IBM is an organization, etc. So this is a piece of text where named entity recognition has actually been carried out, right? So there are a number of ways of carrying out named entity recognition. So some of the NLP tools you can have: lexical and morphological analysis, noun phrase generation, word segmentation, semantic and discourse analysis, word meaning, knowledge representation, knowledge based approaches. Okay, and these are some NLP tools which are there. Okay, you have Stanford's NLP suite, where you also have the NLTK, okay, and you have other NLP tools which are there. Okay, you have also software like Hugging Face. You have R, which has a number of available models for NLP. Okay, you can also use things like Java, JavaScript, etc. These are other software for dependency parser, morphological analysis, phrase structure parsing, speech recognition, etc. So these are all different softwares which are basically available. And some of the NLP applications: information retrieval, summarization, sentiment analysis, information extraction, question answering, dialogue system, etc. right? And if we look at some of the recent research, generation of realistic rhymed and theme based poetry, which is some type of creative writing, generation of theme based short stories, generation of theme based novels, generation of news, short articles, etc. Right? And then natural language understanding, sentiment analysis, text summarization, information extraction, topic analysis, etc. And other areas of research include things like visual question answering, automated image captioning, right? Opinion mining. So you have a product and you have people's feedback online, right? They will give you a feedback, say between 1 and 5, right? For each product. So from that, can you do some type of opinion mining for a particular product? Event recognition, spatiotemporal anchoring, topic modeling, text mining. So these are some models which are available, like BERT for NLP models. ELIZA was a very old one in the mid 1960s. GPT-3, Lambda, etc. Okay, so you find obviously it has a lot of benefits using NLP, right? And nowadays most of the NLP is done by using deep learning algorithms. Okay. Okay. So that will cover NLP applications and tools which are there. Okay, so we'll stop at this stage.